Hi everybody, welcome back. Today we're doing a review lesson on the amount of an annuity, a present value of an annuity, a regular payment of an annuity, and future value versus present value annuities. So the amount of annuity. So when people pay for things, they typically repay the loan with the sequence of payments made at a regular interval. Likewise, people may invest a specific amount of money each month in order to pay for their child's education, vacation, or retirement. What are the scenarios examples of annuities? So let me walk you guys through the definition of those things. An annuity is a sequence of equal deposits or payments made at a regular interval. In an ordinary simple annuity, payments are made at the end of each compounding period. An amount A of an annuity is the sum of regular deposit plus interest. The amount of an ordinary simple annuity is given by the formula A equals to R 1 plus I power n minus 1. In this case, A is the future value, the R is the revenue, the I is the initial value, and the interest rate per compounding period, and its time per year. So let's go into practice. The A equals to R times 1 plus I power of n. In this case, the R, which the revenue, is 200. The interest rate per compounding period is 0.05. The time per year is 3. So A is 200 times 1 plus 0.05 power of 3 minus 1. I calculate 630.5. So like this. The revenue is $1,000. The initial value is 0.08. The time per year is 7. The A equals to 1,000 times 1 plus 0.08 power 7 minus 1 divided by 0.08 because the initial value. And that the answer is 8922.80. So let me practice with you guys. So in this case, they have time of payments, length of annuity, interest rate per year, and frequency of compound. So in this the case, question A is annually, so it's 1. So A equals to R times 1 plus 0.03 power 7 minus 1 divided by 0.03. So the B is semi-annually, so it will be 2 years. Sorry, 2. The B, so divided by 2 is semi-annually, so E equals to R times 1 plus 0.09, 2 minus 1, divided by 0.09. So in this case, the supposed $450 per deposit end of each quarter 1.5 years into annuity that earn 10% per year, compounds quarterly. So and time per year is 4. So 6 years to 6, so 4. So A equals to quarterly. Divided by 0.1. So I didn't bring my calculator, so I might get computer. Sorry guys. Let me get my computer. Wait a second. I'm working hard to make sure everything's correctly. So let me wait for you guys. write down your answer as I'm starting my computer. But as we can tell is here's the A, which we didn't get, minus Rn. Rn is actually we have it. Actually it's 6 here. 6 is 3472.02. My bad. It's 6. It's not 4. I'm sorry. What's 3472.02 minus 2700? 72.02. Actually, like things can get mistake. But anyways, there's more practice. So in this case, the revenue is $400. Initial value is 6.5% divided by 12, so 0.0054, because compound monthly, so it's 12 divided by 12, so 12.56t. That's 5 years. First off, A equal to 400 times 1 plus 0.00454 power 6t divided by 1 divided by 0.0054. It will be 28255.01. So minus so this one minus 24,000 is 4255.01 or stuff. Anyways, we know how to use it. So the homework, I'm not gonna explain too much. All we need to do is that A equals to R times 1 plus I power of n minus 1 divided by I, and the I equals to A divided by A minus Rn, not divided. So let me jump into the present value of annuity, because we don't have too much time to explain too much. So the present value of an annuity. The present value of an annuity is how much money must be invested today to provide regular payments to the future. So the present value is PV equals to R times 1 minus 1 plus I, power of negative n divided by I. So as the present value is negative exponent. So PV is present value, R is revenue, the n is number of compounding period, I is initial value. So in this case, the deposit should be withdraw. So it's $700 times 1 minus 1 plus 0.0045 in the power of negative 8. It did is 5.828. So 8, the initial value. So I minus Rm minus P. I equals to Rm minus PV. So the 5600 minus 5488.28 is gonna be 111.72, like this. So let me continue. So for this one is the revenue is 1500. The initial value, the numbers compounding period is 0.0625 divided by 12, which costs the 0.0052, and is 240. So the PV, I would say we use the 1500 times 1 minus 1 plus 0.052, the power negative 240, like that. And then we got the answer of 205,382.26. So we use the 1500 times 240, and then minus the 208,382.026. And then what we did was 154,617.74. That's what we got. But anyways, all we need to do is to remember PV equals to R times 1 minus 1 plus I power negative n divided by I. And also the other formula, which I can tell is I equals to Rn minus PV. So there are so much things I'm not going to talk about the homework because it is the practice So with the practice, I will do it myself. You do your own. I will find questions from ChatGPT. So lesson 3, the regular payment of an annuity. So as we recall, the annuity equals to revenue times the 1 plus the initial value power of number per year minus 1 divided by I. The PV equals to R times 1 minus 1 plus n divided by in the power negative n divided by I. So the AI equals to R times 1 plus I power of n negative 1. So R equals to AI divided by 1 plus I power of n minus 1, like this. For example, this, so we get the initial value. So 6,000 times 0.03, if it 1 plus 0.03 power of 10 negative 1 equals to 523.38. And the n is 10. Look at that. So let me talk about the present value. So for this is the present value. So we divide the negative. So R equal to 1200 times 0.01, and then divide by 1 minus 1 plus 0.01 power of 38. It got 39.86. Let me see how it got this correctly. I will pull out the Google Classroom answer because actually it's lesson 2. Let me see what they got for this solution. Let me check the solution. Let's see. Present value of an annuity. Actually lesson 3, I pulled the wrong thing. I don't know why I'm always pulling out the wrong thing. Let me see solution. Let's see. This is a very funny solution. And so this one, A. So the number 2A. There's example 2. I need to release it bigger so I can see clearly. Present. It is it's future value. Yes. So A is 23,000. I followed all the procedure. Oh, A differences. Oh, it's 40. No. So I did this wrong. So R equals to 20,000 0.016 by the 1 plus 0.016. 40 minus 1. So, I know why I did this, why I got wrong. I used the wrong calculation idea. So, the homework, I don't want to talk about it because I will know this. So all I need is to get the problem from ChatGPT for practice tonight. I will practice with ChatGPT. Anyways, we're going on the last lesson, which is the annuity future value. So Tom, he invested $100 for revenue. The numbers of compounding period is 480. because it's compound annuity. And then the initial value is 0.0067. A equals to 100 times 1 plus 0.067 in the power of 480 minus 1. Divide 0.0067. 353,186.11. So BEF is R equals to 500. N equals to 240. I equals to 0.08 divided by 12, which is 0.0067. Equals to 500 times 1 plus 0.0067 power 240 minus 1 by 0.0067, which is 295978.47. Just for Tom, he invested $48,000. For Beth is to 120,000. Like this. Tom made the money that's minus, use the 350,168.11 minus 48,000 is 305,168.11 times 11. The BEF is same. Use the 295,978.47 minus the 120,000 with 175,978.47. So Tom invests so much in BEFs, so much less, longer time to earn compound interest. So the present value, I don't think there's anything to talk about. So anyways, it's the end of the lesson. If you like this lesson, please subscribe to me. But for tomorrow, we have to do a good job in the math test to prove Miss Cylka is a pig.